Geometry Unit 2, Lesson 14. What's cool is we're starting here with bisecting things. Why does this construction work? So if your partner A, explain to your partner what steps were taken to construct the perpendicular bisector in this image. If your partner B, listen to your partner's explanation and then explain to your partner why these steps produce a line with the properties of a perpendicular bisector. Then work together to make sure the steps in partner A's explanation have a reason for partner B's explanation. All right, we're going to go to GeoGebra and construct one, okay? So I'm trying to construct a perpendicular bisector of that segment, and we can do this. Okay, we've practiced enough. It's not difficult. We know why it works because we use circles to construct it. Okay, so I'm going to draw a circle, and it just has to go past the middle. Like, that's not past the middle, maybe it is. I just want it to go past the middle. Okay, and I have to copy that same circle. I need the same radius to go on the other side. So I'm going to copy it using the compass and put it at B. Now those two circles intersect at a spot that makes a perpendicular line to segment AB. And so we're going to draw it. I'm going to go ahead and prove that it is perpendicular and bisector by doing that. So let's measure this. A to F, F to B, 2.9 each. And let's go ahead and measure the angle from here to here, 90 degrees. So if that's 90, they're all 90. Okay, because I can do vertical angles, I can do linear pair, supplementary, all of it. Okay, so that's why it works. Cool, cool. Okay, construction from definition. So Han, Claire, and Andre thought of a way to construct an angle bisector. They use a circle to construct points D and E the same distance from A. Hold on a second, I'm going to check something out. This is going to make way better sense. So Han, Claire, and Andre thought of a way to construct an angle bisector. They used a circle to construct points D and E in the same distance from A. So I drew a circle first, then I drew ray through here, ray AC, I drew ray AB, and they're both radii. So AC is equal to AD because I constructed them both as the radius of the circle. When they connected D and E, oh, hold on. This needs to be, nope, we don't want that. Sorry, I thought I was here. This has to be the same letter, or it's just too hard to figure out. Cool. Then they connected D and E and found the midpoint of segment DE. So I haven't found the midpoint yet. They thought that ray AF would be the bisector of angle DAE. Mark the given information on the diagram. So they found the midpoint. How they find the midpoint, they used circles, just like we just did. I'm actually going to use this tool just so I have less things on my, less construction marks on my GeoGebra, because it gets a little messy. So that's the midpoint. So I'm reading from your book, Han's rough draft justification. F is the midpoint, F. F is the midpoint of segment DE. I noticed that F is also on the perpendicular bisector of angle DAE. Okay, we didn't make a perpendicular bisector, did we? Let's do it real quick, and then I can always erase it. So I want to go past F. I'm going to make my construction point down here, though. And then copy it. And then we're going to just do a line. Oh, nope, I have to mark the point first. I have to find that. There it is. I always have a hard time finding it. So now let's do the line. It goes right through A, doesn't it? Okay. Now I'm going to go ahead and delete those things because I don't want to deal with them yet. And they're super easy to reconstruct. And that's everything. I don't need this point either. Okay. I noticed that F is also on the perpendicular bisector of DAE. DAE. Perpendicular bisector of angle DAE. I don't have a perpendicular bisector of an angle. I have a perpendicular bisector of a segment. I can perpendicularly bisect here, but no, not there. So Claire's rough draft justification, since segment DA is congruent to segment EA, triangle DEA is isosceles. She's pretty smart, isn't she? So these are congruent, therefore it's an isosceles. That means these angles are congruent too. Okay? DF has to be congruent to EF. DF has to be congruent to EF because they are the same length. So AF has to be the angle bisector. These are congruent because they're the same length. So AF has to be the angle bisector. That means those have to be equal. All right, I think she has some holes in her argument too. It was good you noticed isosceles triangle. What else can you say is true because the triangle is isosceles? We also know, like we said, that the base angles, if we constructed this, we can say that those are congruent and that's congruent, and that is side to side. No, hypotenuse leg. No, we haven't done hypotenuse leg yet. Let's do that again. So we know this, we know that. And did we say that? Did Claire say she knew? Oh yeah, because it was we know this. Oh, too many lines. Let's start over. We know this, we know this, and we know this. So that is side, angle, side. So we know the triangles are congruent. If we know the triangles are congruent, we know that this is congruent to this, CPCTC. We know this is congruent to this, CPCTC. When these two are congruent, they also are a linear pair. So angle plus angle equals 180. Two angles equals 180. One angle equals 90. There we go, perpendicular bisector. Good job, Claire. You just needed to finish. Andre's rough draft, if you draw a segment from F to A, it's going to disappear in a second. What if you draw a segment from F to A? Segments DF and EF are congruent. Also, angle DAF is congruent to EAF. DAF. I don't think he knows that. So we don't know that DAF is congruent to EAF, do we? Okay, so that last guy has some holes too. Okay, now each student tried to justify, using the ideas you heard in ways each student could make their explanation better. Write your own explanation for why AF must be an angle bisector. I can do that in 1 second. I needed to be able to draw so that you could see it for longer periods of time. So we are trying to prove that AF is, what are we trying to prove? Must be an angle bisector. Okay, so we know that AD is congruent to AB because they are the radius of the circle. And we also know that AF is congruent to AF because it's reflexive. Ooh, I'm not going in a very good order here. Let's go in a good order because I know you're practicing that on your math too, on your practice problems. So triangle DAE is isosceles. definition of isosceles. When you know two sides are equal, you can call it isosceles. Now I can say that angle D is congruent to angle E, same reason. So let's go ahead and mark that. And I can mark this. AF is congruent to AF because they're reflexive. Now we have, and I can mark this. Because we constructed, we would go up here, F is midpoint of DE given, because that's how we made it. So DF is congruent to EF. Definition of midpoint. Cool. Now I can say that triangle ADF is congruent to triangle AEF. And I can use either side, or side, angle, side. Doesn't matter, does it? Cool. Now, once I've said the triangles are congruent, I can say that angle DAF, can't read that, can you? DAF is congruent to angle EAF, CPCTC. And once I say those are equal, I know that AF is an angle bisector. Therefore, AF is the angle bisector of DAE, angle DAE. We did it. Cool. All right, construction from definition. We already did that. I don't know why I put that so far up. I'm so sorry. Okay, so we did task 2. Task 3, reflecting on reflection. Okay, pause for a second. I'm going to read this because it says it's optional. I want to make sure we need to do it or not. All right, this one says that I have an isosceles triangle, segment AP congruent to BP. Here's a valid proof. Read the proof and annotate the diagram. So let's go ahead and do this. I'm not going to do part B where it says write a summary of how this proof shows the angle bisector of the vertex angle of an isosceles triangle is a line of symmetry. Let's go up here because we have an isosceles triangle with an angle bisector. Just to talk about that second part, it's saying that this is a line of symmetry, which is very true because it cuts. I've got this triangle right here, which is congruent to this one, and it's a complete reflection. Okay, I could actually reflect it over segment AF, and all of the vertices coincide. All right, so I'm not going to write that summary, but I do want to annotate this diagram. That just means we're going to mark it up. Mark it up with what we see, or what we read. Segment AP is congruent to BP. Got it, because it's isosceles. The angle bisector of APB intersects with segment AB, call that Q. That's a beautiful straight angle, or straight line. Q. By definition of angle bisector, angles APQ and BPQ are congruent. I wish this diagram were a little bigger. Segment PQ is congruent to itself. By the side angle side congruence theorem, triangle APQ and BPQ must be congruent. Okay, we have angle, side, and side, angle, side. So now we know that this piece is congruent and this angle is congruent. I can't do, I'm just going to change colors. All right, and let's change colors again. It's so small. Those two angles are congruent, all right? So therefore, the corresponding segments AQ, BQ are congruent, and corresponding angles AQP and BQP are congruent. I just marked all of those. since angles AQP and BQP are both congruent and supplementary, each angle must be a right angle. Yes. So PQ must be the perpendicular bisector of AB. Yes. Because the reflection across the perpendicular bisectors takes segments onto themselves and swaps the endpoints, then we reflect the triangle across PQ. The vertex P will stay in the same spot, and the two endpoints of the base, A and B, will switch places. Yes. Therefore, the angle bisector of PQ is a line of symmetry for triangle APB. Yes. That was fun. All right, so let's do this one. We're going to annotate, and then if we can, find the errors. All right. Okay. And I looked ahead. It's that one, but we're going to see why. So, the diagonals of parallelogram intersect. Call that point M. Check. The diagonals of a parallelogram bisect each other, so MB is congruent to MD. MB, MD. Check. By definition of parallelogram, the opposite sides, AB and CD, are parallel. Congruent. Oh no, by definition, they're parallel. Erase, erase. Check. Angles ABM, ABM, and ADM, ADM are alternate interior angles of the parallel lines. No. ABM is here. It's congruent to this one. So ABM is congruent to ABM, CDM. Therefore, step 5, AM is congruent to itself. Okay. I don't think we want AM. Therefore, that one doesn't matter. But we know that AM is equal to MC because the diagonals bisect each other. So this one, that's true, but it's not helping us. We don't like it. AM is congruent to itself. That's a segment. So by the side angle side congruence, so this one is now invalid because we did not do ABM, ADM. Yeah. So they were going for those two triangles, so we're just going to stop there. That doesn't work. All right, we're just going to cut it. All right, we had 3 in a wrong row, so we know that doesn't work. Cool? All right. That looks fun. Oh, that goes for a cool down. Sorry. Hold on. I'm going to get something. This was just an extra added part of the lesson, but I think it's really fun. So let's see. If I told you segment FA was a line of symmetry of this triangle, what else can you tell me about that line? It's a perpendicular bisector of DE. Okay, if this is a line of symmetry, that means that's going to go over there. I could fold it in half. This triangle and this triangle are congruent. F is the midpoint of DE. You could also say that. That's true. Yeah. If triangle ADE were not isosceles, would it still have a line of symmetry? No. That means that, let's do this. If these two are not equal, let's just mark them like that, then AF is not a line of symmetry. All right, the fact that these are equal makes AF a line of symmetry. I think there's thunder up there. If triangle ADE were not isosceles, would the angle bisector of DAE, and would this bisect, and would that be equal? No. Okay, those being equal means everything. So now it says, using the applet, move D or E so the triangle is no longer isosceles. I don't know if I can. Ooh, that's so cool. So my the line of reflection, the line of symmetry just moved. Okay, that is so cool. So which line is the angle bisector of DAE? I think it's F. Which line goes from A to the midpoint of DE? Which line goes from A to the midpoint of DE? I think it's F. It could be G. I think it's F, though. I can't really tell. I don't know if I can measure them. Nope. Which line is perpendicular to DE? None of them. Okay? That's so cool. Now I'm going to show you the circle. Okay, we're no longer on the circle. If I get them on the circle, then all the lines are together, right? If I take it off the circle, and it's not. So AH is still perpendicular to DE, but it's no longer a bisector. And AF is a bisector, but no longer perpendicular. All right, that's cool. Good job.